Okay, bonjour tout le monde, salut, bon lundi. Welcome everybody. This is our Montreal DevOps Meetup. We're super excited to have you all here, super excited to be here. Ça fait longtemps qu'on s'est vu en personne, mais aussi virtuellement. So DevOps Montreal has taken a little bit of a pause, not really on purpose, but mostly due to COVID / other things coming up for people who are organizing. So we thought we'd take a stab at reviving this. Donc, si ça vous tente de faire partie de l'organisation ou de faire un talk, on va en parler bientôt, mais laissez-nous savoir si jamais ça vous tente. If anyone is interested in wanting to help us organize another event, please ping either myself or Ian or anyone on here, write it in the chat and we'll talk about it. So we're going to get going. So welcome to our online meetup. I am Julia, and I'm here with my co-host Ian, and we're going to walk you through this wonderful experience today with our two great speakers. So we can move forward on that slide, please, Ian. There's us. So I work at CloudOps. I've been there for about 6 years and fairly active in the community. And this is my wonderful co-host, Ian Crosby. He works at Container Solutions. So Ian and I have been doing a lot of meetups, and we're also both on the committee for DevOps Days Montreal. So we're very happy to bring you this meetup. Here's what we're going to do. We're going to try to get through this intro pretty quickly so that we can stay on time. We're going to have a talk about Terraform and Terragrunt, and then we're going to have a talk about Kubernetes Operators, aiming to end at 1, so we can set everyone free for lunch and other things. These are wonderful speakers. So we have Kevin Sagle from CloudOps, and we have Sebastián Gómez from Container Solutions. So it just happened this way, but we're super grateful to have you guys here. Welcome, and thank you so much for presenting on these talks, both really relevant topics in the industry today. So we'll start with Kevin, and then Sebastián will go. And if you have any questions, there is a Q&A enabled on this webinar. So please put any questions for the speakers into the Q&A. But please feel free to use the chat. Vous pouvez poser des questions en français. Vous pouvez écrire dans le chat en français. Puis on va traduire si jamais c'est pas complètement à 100% compris. Donc sentez-vous bien à l'aise d'interagir avec nous en français aussi. All right. And then, of course, we must thank our sponsors because CloudOps and Container Solutions are providing the support and the time for these presentations today. So we want to give both companies a shout out for helping us. And I think with that, I'm going to pass it to Ian.
Cool. Thank you, Julia. So just a couple more things to go over before we get started. How can you stay in touch? So yeah, we're kicking back off this DevOps Montreal community. So there are several ways. QR code there for the meetup link. And there's another QR code if you want to submit a talk, if you're interested in speaking at a future one. There's a link there to a Google form, I believe. Also, just feel free to reach out to myself or Julia directly if you have questions. Ideas, things you want to see or improve or get involved. There's also Twitter, DevOps Montreal. Feel free to interact with us there. Again, if you have any questions, thoughts, or ideas. So last year's DevOps Days Montreal was obviously canceled with the current situation. We'll see what this year brings. Hoping to bring it back, but of course we'll see what happens this year. And yes, hiring. Everybody is hiring. So if you would love to work at one of these wonderful DevOps companies that is presenting or sponsoring today, you can feel free to reach out. Also, there's more than that. A good place to find information is on the DevOps Montreal Slack organization. If you are not on there, reach out again to one of us or send a DM to the DevOps Montreal Twitter, and we will send you over an invite to join there. There's job postings, interesting discussions, and lots of stuff going on there. So I think without further ado, we will jump over to Kevin for the first presentation.
Thank you, Ian. You stop sharing your screen.
Yes.
Thank you. So welcome everyone. Oh, can you guys hear me still? Perfect.
Yeah, you're good.
So welcome everyone. My name is Kevin. Today I'm going to be giving you a talk on Terraform and Terragrunt and how you can use Terragrunt to improve your Terraform code and write clean, reusable code by reducing state scope and managing dependencies. Oops. First off, a bit of an intro. My name is Kevin Sagle. I'm a cloud solutions architect at CloudOps. CloudOps is a cloud consulting, managed services, and software company focused on open source, cloud native platforms, networking, and DevOps. As Ian mentioned, we are hiring, so there is a link down there at the bottom, as well as a QR code, and both those will be available in my last slide while we do Q&A as well. So we're going to be going over a couple things. First, we'll discuss what Terragrunt actually is and how it works. We're going to go over some of the major benefits that it can give you. I'll go through a couple of tips and tricks I've picked up over the past 6 months as I've been using Terragrunt for a project. And if I time things right, we should end up with a little bit of time at the end for some Q&A. A little bit of background on how I came to start working with Terragrunt and how it became so useful for us. We initially designed a Terragrunt playbook to deploy a relatively complex infrastructure on AWS for one of our clients. We initially did that around 2 years ago, and since then the requirements have changed a lot, but our code has kind of hasn't been really improved to meet their new requirements. One of the big problems with this was that we had several separate components that really were treated as independent Terraform playbooks. Some of the outputs from one playbook would be required by the other, but there wasn't really any way to do that automatically. So we ended up writing a whole bunch of helper scripts that would deploy one, it would parse the output, and then it would put that in as the input variables for the next Terraform playbook. This worked relatively well when they weren't deploying a lot of new environments very often, but as they deployed more and more, this kind of became very long in the tooth. Deploying environments required making sure that you had set up the helper scripts correctly so that would find the right paths and use the right variables. And it just really didn't scale well. One of the asks from our end client was that they wanted to be able to manage deployments on their own when we completed the new project. So since we were going to be redoing a lot of the work anyways, we decided to take a step back and see if we could really nail down a way to make this easier for them and in turn help us reduce their dependence on us. So what Terragrunt is, it's a tool designed by gruntwork.io. In their words, it's a thin wrapper that provides extra tools for keeping your configurations dry, working with multiple Terraform modules, and managing remote state. One thing I really want to highlight here is the thin wrapper portion. Because of how Terragrunt works, you can start using it very easily without actually ever touching or changing your Terraform code. You can essentially write it side by side and you point it at your normal modules and you can get a sense for how it works without changing anything. Then you can see if it actually does provide value to what you're trying to deploy. And if so, you can take a closer look at how you can actually integrate it in the longer term. So how Terragrunt works at a high level is this. In your configuration for Terragrunt, you point it at a source Terraform module the same way you normally would when you're calling another Terraform module. That source is cloned into a local Scratch directory, And the source can either be a local directory, source, or a Git repository, or any other kind of private repository where your code lives. So that source code is cloned into a local Scratch directory, which is very similar to the Terraform Scratch directory you get anytime you actually run Terraform. Then Terragrunt parses your Terragrunt configuration files and does a couple of things. There's some functionality around before and after hooks we'll get into a little bit later that let you run scripts before you actually run your Terraform, so you can create new files, for instance, your backend or provider files, or your versions.tf, stuff like that. It also has a lot of functionality around actually defining what input variables you're going to pass through to Terraform. Terragrunt then moves into the Scratch directory and it runs Terraform, passing through your environmental variables, as well as any command line arguments you've passed through to Terragrunt. What this means in practice is that all the commands that you normally use with Terraform will work with Terragrunt with minimal changes. For instance, if you run Terragrunt plan, it's going to copy your source directory, do some configuration, and then it will actually run Terraform plan in your Scratch directory, and it will behave the same way. The same is true of any other Terraform command, whether it's planning, applying, destroying, or things like targeting. So one of the biggest and I think most useful functions of Terragrunt is allowing you to do dynamic backend configuration. One of the big pain points we ran into as we started to work on this project to simplify the deployment for our customer was that we didn't really have a good way to manage the components as a group. Each individual component or modules had their own backend configurations, and these were configured pretty statically, which is just a function of how Terraform does the backend configuration. When you're doing the configuration, you can use some expressions, but it's pretty limited, and the values you use have to be known before you run Terraform. Terragrunt, on the other hand, lets you include various configurations from different parts, from different folders or different files. This allows you to, for instance, set up a configuration for your backend in the root directory and inherit that by your child modules. It also provides a bunch of different functionality that lets you dynamically define some of those variables. So having a look at how this is often done in Terraform, this is a pretty common design pattern. We've got a config module and we've got a modules repo here. Now I'm using local files here just to show you how this works, but generally these would be two separate repos in some kind of source control. Now in your dev and in your prod folders, you've got this configuration stuff that's going to determine how Terraform actually runs. You've got your backend configuration, where we've got your bucket, your key, your region, stuff like that. You may also have your provider configuration. And really the only difference between the configuration for our prod and our dev environments here is this key, where we've got prod. So for dev, that would be dev. This is the way you separate your states into different files. This is fine when you're deploying relatively small environments, but if you're deploying and creating new environments very often, it becomes a little bit hard to manage. There's also some risk that you run your playbooks and if you're using the wrong state files, you may end up using the wrong state, which can cause a whole bunch of problems. Let's see how it looks in Terragrunt. So this is Terragrunt, and as you can see, we've removed all the TF code from that configuration repo. So we're no longer actually running Terraform from there. We've got a root terragrunt.hcl along with another terragrunt.hcl in both of those environments. In the child terragrunt.hcl, so the one in dev or the one in prod, we're using a terragrunt function that's called include, and we say find in parent folders. What this function does is it crawls up through your directory structure and it tries to find the root terragrunt.hcl file. It then includes all of the configuration from that file into this configuration. So in our root terragrunt.hcl in this case, we've got this remote state block. We're configuring it to use S3, and we're using another Terragrunt function called generate. What generate does is it allows you to create files within your Scratch directory before Terraform is actually run. So in this case, we're generating the backend .tf that we were previously statically defining within those environments. We've got this configuration block that's actually going to set it up. And in key, before where we had the explicit name of the environment, prod or dev, we now have another Terragrunt function called path relative to include. What that does is it simply returns the path from where it finds the root Terragrunt configuration file to where you're actually running Terragrunt from. So if you're running Terragrunt from within dev, it's going to return dev. If you're running it from within prod, it's going to return prod. One of the big things that this allows is that these files are now identical. If we wanted to deploy a QA environment, we could just create a QA folder. We could put the same terragrunt.htcl in there, and when we deploy it, it would automatically have this new path. When you're deploying a lot of different environments, this really becomes very useful. Additionally, because we've got S3 bucket defined here, because we've got the backend defined here, it's much easier for us to change to another cloud provider, for instance. We just need to change the configuration in this one file, and then it will be automatically updated in these ones, as opposed to having to go through each backend.tf in all your environments and change where it's pointing to. It also means that when you go into your bucket where you're storing your state, it's always going to have consistent pathing, which makes things a lot easier when you're trying to figure out where things actually are. Now I'm using this function here for the key, but you could just as easily use it for the bucket or any of these other places. Also, while I'm using generate to define the backend.tf, the same functionality can be used to define things like your provider.tf, your versions.tf, or any other number of arbitrary files that you may need to make use of during your Terraform run. The dynamic backend configuration also leads to another big benefit of using Terragrunt, which is state management. In Terraform, you generally have a state per backend or per module. In large, complex deployments, these can easily end up having hundreds of thousands or even millions of resources graphed together. As they grow, the length it takes to actually run your whole playbook grows and grows as well. The longer this takes, the harder it is to make changes because you need to troubleshoot. Because when you try to troubleshoot, it's going to be another 10-minute run, for instance. And it's also tough to narrow down what's actually happening because of all the resources you're managing. Additionally, when you're using Terraform native backends, you do have to configure the bucket beforehand. So if you're using S3, you need to create that S3 bucket and make use of in order to make use of it using your Terraform code. Terragrunt has a few benefits here. Because the backend is configured dynamically, you can reduce the state of your scope to be as narrow or as wide as you like. Smaller states let you make changes quickly to specific modules without having to worry about impacting outside modules. Terragrunt also gives you a few functions that we're going to discuss a little bit later that help you manage these all as a group while still having the advantage of those small state files. Terragrunt also supports all the same backends as Terraform, and a nice feature of it is that we'll actually create the S3 buckets or whatever other backend you're using automatically and add them as managed resources within your Terraform run. While that's not a big thing, when you're changing between providers or when you're testing different providers a lot, it adds up, and it's just some nicety that helps out. So to give an example of how this smaller state scope looks in Terragrunt, we're going back to our initial demo app. Now, in this case, you probably wouldn't need to split out the state files to be this small because there's only a couple of them, but there are times where it is beneficial. So in our prod folder, we've now created an app and a VPC folder as well, and these map to our app and VPC modules. Because we're using that dynamic backend configuration, if we run Terragrunt from within the app folder, it's going to create its own state file. So when you run it from dev, you're going to end up with a state file that has the resources managed by the root module in the dev folder. And then when you run it from app, it's going to have the state file for those resources in here. A way this is really useful is if, for instance, you're deploying a Kubernetes cluster and you have a module specifically designed for doing that. If you want to make sure that you're only affecting that one, so you want to be able to tear it down and start it back up without impacting your load balancers in front of it or any of the other resources, By doing this, you've got a very narrow scope where you can interact with it and change it without having any impact on the other stuff. You're also able to quickly run and target just that resource, which is pretty useful. You can do something similar by targeting resources with Terraform, but HashiCorp themselves don't recommend it because it can lead to inconsistent states, which will give you all kinds of headaches when you're doing large, complex deployments. Next thing I want to talk about, and this is really where I personally saw the most value of Terragrunt, is how it allows you to dynamically define input variables. So when you're doing deployments in Terraform, you often have a variable file where you're going to define all your variables and how and what types they are, stuff like that. These are pretty static and you don't have a lot of flexibility in how you name them or how you actually configure them. Terragrunt gives you some added benefits here. In the same way that we included the backend configuration, we can include input variable configurations and use those within our run. So here's how this looks in Terragrunt. We've added a couple of files here, an nvars.hcl file and a gvars.hcl file. Now in this case, I'm just going to demonstrate using tags, but you can define anything in here. For instance, if you've got a global logging API URL that's going to be used for all your environments, you could define that in here. Then we've got our env tags, which is just stuff that applies only to your environment, whether that's dev, production, QA, or any other name. Because we've defined these in the HCL files, and here's how the actual terragrunt.hcl code looks for these. We've got a locals block that anyone who's done a lot of Terraform code is probably familiar with. Essentially, it's just making these variables available to the rest of this configuration file. And in it, we're going to use another Terragrunt function called read Terragrunt config. In the case of nvars, it's going to look just in this folder for that nvars.hcl, and it's going to import those inputs. And in the case of global vars, we're once again using the find in parent folders function so that it will crawl up through the structure looking for that gvars.hcl and import them into this configuration. Then, just as an example, we're using the tags variable, and we're going to get a merge of those two tag maps. The inputs block is really where the magic happens. This is where you define what you're actually going to pass through as TF-vars to your Terraform run. In this case, we're once again using the path relative to include for the env. So if you run this from prod, it's going to show prod, or dev, it'll show dev. Then we've got our normal Terraform block where we're defining the source. This is what's going to be cloned into that Scratch directory. And it, once again, can be a local folder, it can be or any other repository. Last big benefit I want to mention is dependency management. So Terraform does have some dependency management, but it is fairly limited. There's not really a good way to use outputs from external modules within your normal plays. Terragrunt also gives you the ability to apply all, plan all, and destroy all. These are commands that allow you to essentially, if you run from the root, it's going to crawl through all your subdirectories looking for your configurations, and it's going to run your Terraform commands from those subdirectories. So before, where we had the prod, web app, and VPC as separate ones, if we ran apply all from within the root prod directory, it's going to go into each of those web app and VPC modules and run Terraform from there. In this way, even though we've got the scope files much smaller with far fewer resources managed in any single one of them, we're still able to run them all together as a group. It also gives you an ability to do mock outputs, which are a way to essentially test a string and see how your code is going to behave if that string is passed through. This is really nice when you're changing how code handles certain variables and you want to make sure that it's going to accept things correctly, or when you want to test things like validation. It's very useful then. And just like when you include other configurations, such as the backend or the input variables, these are going to be referenceable throughout the rest of your configuration. So here's how this looks in Terragrunt. So we've got our config folder, and we've got a prod, and then within prod, we've got an A environment, a B environment, and a common environment. Imagine that you've got a common environment that's going to deploy things like that are all shared resources. For instance, it could be a Bastion host that's going to be used to deploy Kubernetes clusters in both A and B. Because we're using the dependency, if we run terragrunt plan or apply all from the root prod directory, when it gets to here, it's going to say, okay, I need this output from common. Let's check if we've got it. It's going to check the state file, or it'll run Terraform output on that module, depending on how you've got it configured. And if that doesn't exist, it's going to say, okay, well, I need to deploy common before I can deploy this. Should I go ahead and do that? And if you say yes, it's going to go through the common deploy. And then once the common deploy is complete, it's going to pass that bastion IP through as an input variable to A and B. Once again, this is really nice when you're making a lot of different environments that are dependent on each other, because it also allows you to do things in parallel. While A and B have a dependency on common, so they won't run until common is complete. Since they don't have a dependency on each other, it's going to run both of those at the same time once common is done. When you're deploying a lot of environments or very complex environments, this can add up to a lot of time savings very quickly. A few other things I just want to talk about are some tips and tricks I've come up with as we've gone through this project. One of my favorite things that Terragrunt provides is the before and after hooks. I mentioned these a little bit earlier, but essentially Terragrunt can run scripts or commands at a bunch of different stages of your Terraform deploy. The most common ones that I've used are before cloning, after cloning, but before running Terraform, and at the end of the playbook. One of the big requirements for our client was that we need to be able to have sensitive values in each different environment that can only be accessed by the people who are authorized, but they did still want to be able to have people outside those groups deploy stuff. So what we did is we've got these encrypted sensitive variable files in each environment, which are decrypted using Ansible Vault using a before hook. So the source repository is cloned down into the Scratch directory. The Ansible Vault is run using an envar, and based on what the password is, it decrypts the sensitive values they have access to and outputs that into the Scratch directory. Then the Terraform code actually runs, goes through its playbook, and at the end of it, it runs another hook that actually removes those plain text values from the Scratch directory. While it's not perfect, it does reduce the time that you've got these plain text passwords available on these hard drives and reduces the risk of having those available if, for instance, a hard drive goes missing. I know that Terraform 14 is actually going to incorporate some of this stuff to allow for encrypted parameters, so maybe this won't necessarily be something that we use a lot in the future, but it was a big help for us in our last project. The other thing I like to do is have a global modules config file. What I mean by this is that I like to have a global file in the root of the directory that defines which version of the modules are being deployed in each sub-environment. So for instance, if you've got dev that needs to be deployed using version 1.0, and you've got prod that's being deployed with 0.05, you would define all of these in a map and use those and include those into your child configurations. Doing this allows you to have at a quick glance, tell exactly what's deployed where and which is on which version. One of the big things we want to do is reduce the need for our client to go into individual configs within the actual environments, and this really helped us out. The other thing I just want to mention is that when you are using Terragrunt, you need to make sure that your variables are defined explicitly in or the type of the variable must be defined explicitly in your Terraform code. The reason for this is that Terragrunt doesn't really have the same concept of objects or maps. It kind of treats everything a bit differently. So when it's going to run the TFVARs, it's always going to be passing those through as essentially strings. And if you don't have those defined explicitly in your Terraform code, you'll end up in situations where it thinks that it's the wrong type of object. Yeah, so I'll open it up to a little bit of Q&A. Once again, I'll just mention that we are hiring for a variety of technical and non-technical positions. So please grab that QR code, that link, and apply if you're interested.
All right, thanks a lot, Kevin. If anybody has any questions at all, anything they want to follow up on with Kevin, feel free to just drop them in the chat. I don't think any came in during the talk. There was one question about recordings. As Julia mentioned, those will be available, posted in the Slack and the Meetup page.
Cool. Well, thank you all very much for listening, and I will hand this over to Ian or Julia, or directly to Sebastian. We'll see.
Awesome. So I think we do have one question actually that just came in. Ian, do you want to do this one?
Yes, I don't see the question.
Sorry.
Oh, Q&A. I'm not very good at Zoom. Right, cool. So the question is, how do you test the introduction of a configuration change?
So I'd say you're going to test it the same way you would test your Terraform changes. So you make your change in your configuration, you run your Terragrunt plan, which is going to end up passing through the same command Terraform into the Scratch directory. Make sure it's running correctly, and then apply it. So it really doesn't change your development pattern for Terraform. It's just changing where you're running the commands and how you define the variables.
Cool, thanks for that answer.
So I think we might get moving on to Sebastián so he has enough time. So Kevin, you can feel free to type answers in the Q&A section because there is one more question from Troy in there. So feel free to type that and people can go take a look at your responses in there. Yeah, so it's happening in there. So we're just going to move on if you don't mind. But thank you so much for your talk. I really liked your
problem.
slide.
Thanks.
Okay, so without further ado, Sebastián, I will pass it to you to tell us a little bit about Kubernetes operators.
All right, thank you. Can you see my screen? That's the obvious question I have to do first. Okay, I get a thumbs up. Thank you. Okay. Hello, everybody. Thank you for being here. Thank you for having me. I will be talking about Kubernetes operators, like Julia said. Wait, what's going on? There it is. Okay, my name is Sebastián Gómez. I'm from Uruguay, that little orange dot down there. I know you all know where Canada is. I'm going to be moving there in a few, I don't know, weeks, months. We're working on it. And very happy to be here. Before joining Container Solutions, I was a developer. I've been writing code for most of my professional life. And so Kubernetes operators are the developer part of the Kubernetes. So that was the fun part for me, and that's why I like them so much. And I hope you, after this talk, you get to know them a little better and understand if you need one or how to get one. So to get started, where we are, I wanted to show this, Gartner hype, cycle of hype, I think it's called. Because if you start wondering about Kubernetes operators and you start Googling, you will see a lot of articles and papers and talks that said, don't write your own operators, stop building operators, don't do it. And there's also a good reason for that. When people developers found out about operators, it's really fun. It's what developers love to do, is have your own code next to some big thing like Kubernetes. So I think we are past that peak of inflated expectations, and we are now getting the right operators for the right job. So if you're familiar with Kubernetes, I hope you are, because it's not the main goal of my talk to introduce you to Kubernetes, but you probably have seen this diagram. This is from the Kubernetes documentation page, and it shows you all the different components that a Kubernetes cluster has. But I like to use this one. This one is from I wrote the name because I don't get it right all the time. It's Mamshad Manambet. He's a guy that writes. He actually created a lot of resources for studying for CKA, the certified Kubernetes administrator courses, and he uses the analogy of a big container ship. Like Kubernetes is a big container ship where every component it has a different analogy there, and he uses the controller manager to explain that is the brain of the ship. That's the controller manager in a Kubernetes cluster is where all the hard decisions are being made. And in this picture here, you can see that the controller manager also has another controllers, the node controller, replication controllers, and another ones, and more that we're going to be seeing here. This one is this is how the deployment controller works. You basically define in your YAML what your deployment will do. In this case, this is a kind deployment. It will have one replica. The image, it will be SQL Server in this case, and it's exposed on port 1433. So how does the controller makes this work, creates pods and everything? Well, it basically has this operator which tracks the resource changes. If you want to have like one more instance of your application, you just change that, apply it, and the operator will check the desired state of the cluster, which is your YAML or however you change that, and your current state. And it will adjust as needed. If you need more, it will spin up more pods. If you declare less pods, it will terminate the pods to everything every time comparing the desired state with the current state, and they have to match, of course. And the way to do this is with the operator pattern. The operator is a pattern very used in IoT, the Internet of Things, where you basically do that. You have a reconciliation, what's called a reconciliation loop, where you check your desired state and your current state and obviously adjust accordingly. So why would you use an operator? I see two main reasons. One of them is using the non-standard Kubernetes objects and extensions. Like if you want to use Prometheus, Grafana, OpenShift, I put some here. Of course, there are hundreds of different components that you can use as operators there. There's an easier management into it because you don't have to install anything. If you want to use Redis in your cluster, you can just spin up the operator and you will get it right away. You don't have to install or have scripts to install a third-party application or resource anywhere. And everything is a YAML file. This, of course, some people love this, some people hate it, but it is an easier way to get into GitOps if you want to. And of course, having it in a YAML in a Git repository allows you to check back the history and do a lot of stuff. So, but in having a demo is part of a meeting, right? A live demo. So I'm gonna go and I can see because of the. Let me move. Can I move? Yeah. Okay. Okay. Let me show you what I have here. I have a cluster with nothing running on. There's. Can you see the font size is right? Yeah. Okay. So there's an empty cluster. It's just the Kubernetes service running. K is my shortcut for kubectl, and I have a file here that I want to show you, which is a database. I want to create a Microsoft SQL Server database, which will be called FirstDB and has some configuration and credentials, and because it obviously has a name. So if I want to apply this, I want to create this database in my cluster, I will get an error because Kubernetes does not know what MS SQL DB is. So you need to create something to tell the cluster that you are creating a new object, a new resource. In my case, that resource is called custom resource definition. Custom resource definition is the way you tell the Kubernetes cluster that you're going to use new resources that he's not aware of. So I declare here the kind, which is MS SQL DB, names, and some properties. DB name, config map, and credentials. This is the name of a config map where the SQL server is installed, is running. And these are the credentials. This is the name of a secret, actually, that holds the credentials to connect to that SQL server. So if I apply this CRD, I can now try to apply the DB1, the MS SQL DB, and it says it has created it. So I can now test if it is here, get MS SQL DB, and it says, yes, there is one. But what is happening here? Kubernetes knows it has saved in its state on the etcd DB that there's a new object called DB1, which is of kind MS SQL DB that's been here for 13 seconds. And that's it. Nobody's actually doing anything with it. So we're building an operator to actually read that and do what's appropriate. So let me first apply the deployment. This deployment, what it did is created the SQL Server instance and the config map and secrets that I told you before. And so now I have a SQL Server running here. Let me get the credentials. Okay, I'm inside the SQL Server, so I can select name from sys databases. And those are the 4 out-of-the-box databases that the SQL Server has. So far, there's nothing new. There's a new object, but nobody is doing anything with it. So I'm going to apply my operator. I think it was controller deployment. Yeah. So this is an operator. This is code that I wrote, and now it's running on a container that is actually querying the Kubernetes API for this new kind of object that he knows, the MS SQL DB, and is running that reconciliation loop that I mentioned before. So if I query again, it should be here. If everything goes as expected, yeah, my first DB is there, right? So the controller just started and queried the DB, the Kubernetes API. The API said there's an object. It didn't say it's new. There's an object called DB1, which refers to this database, my first DB. The controller went and queried if that, for the current state, if that the database was created, and since it wasn't there, it went ahead and created it. And I can try to drop it. Drop database, my first DB. I'm not deleting the object on the Kubernetes cluster. I'm just dropping the database. And if I query again, you will probably see, yeah, that is already there. And why is already there? Because the reconciliation loop ran, and it actually found that the database was missing. I wasn't fast enough. So let me show you what I mean. Controller, here's the log. You will see that, yeah, there's a warning here. It found that the DB1, my first DB, was not found and needed to be created, and it actually successfully created in less than a second. So that's why I wasn't so fast to show you what had happened. So everything good, Bill? Yeah, all right. Okay, so that was the Microsoft SQL Server operator demo that I wanted to show you. This is just a demo, it's not ready for production. If your database gets dropped, like I did, your most silly problem is get the database created again. You have to create your tables, your data. Nothing is done with that operator. That's just for this demo. Please don't use this in production. This is a sample from the .NET Operator SDK, which is something that we built at Container Solutions. There's the link there in case you want to try the same demo. I'll share the demo, the link at the end also. But I wanted to share with you, I want to see the time, yeah. I wanted to share with you a real life scenario of an external operator. And this is something we built at Container Solutions too. It's called the external secrets operator. The external secret operator allows you to have your secrets for your application on a really secure place, like Azure Key Vault, AWS, Google, or whatever. If you're familiar with Kubernetes and their secrets, you know they're not secret enough. I mean, that's just, you can have your secret in your repo. So we created this external, this operator that actually, once you feed them the configuration, the secret recipe, it will go to your cloud provider, whoever you define it, and it will get the secret and create an actual Kubernetes secret with your credentials, with the secret that you wanted to share. So yeah, this is basically what I just said. You can store your secrets on one of these backends. These are the ones that we are supporting right now: AWS, CredStash, Google, GitLab, and Azure Key Vault. I actually work directly on the Azure Key Vault, so I can answer questions there. And yeah, it basically injects the secrets, the secured credentials from your secrets as native Kubernetes secrets. I'm using too many secrets, but I'm not talking about the same things. One thing is the Kubernetes secrets, which is a native Kubernetes object. And then I'm talking about the secrets that you create on your secret manager, for instance. And yeah, this is an active project. It's ready for production, and we're working with other members of the community, GoDaddy and others, to make it hopefully native into Kubernetes and hopefully get it out there for everybody. But you can start using it today. So now you have two choices. You know what an operator is, or you have the new idea of what an operator is, and you can get the red pill and forget everything and go back to where you were before, or move forward. And if you do move forward and you think you need an operator, you should first think of, is there an operator that I can use already? And here are two good resources for checking that, checking if the operator that you think you need isn't already there. Most probably, if you're going to use a third-party application, there's probably an operator already there. So if you go to operatorhub.io, and you search the operator that you want, maybe Postgre, MongoDB, Redis, obviously all the ones that I already mentioned are there. SQL Server is not there, and that's why I created that demo thing. But yeah, you should check if your operator is not already there. But otherwise, you could build it. If it's something very specific for your application, something that is only for your domain, you probably have to build it. And if you have to build it, you have some options. You could use the official operator SDK that's written in Go. Kubernetes is written in Go. So that would be the most, I don't know, the nature way to go. But probably you don't have the skills to write Go, and you don't want to hire somebody new to write Go, and you have the skills for another programming languages like Java, .NET, JavaScript, Node.js. So there are other operators, SDK or frameworks that you can use. Java is very popular. .NET is the one that was used in the demo that I showed. And I haven't used the Node.js one, but I know it's out there too. So you probably, if you are new to the Kubernetes operators and you want to start building one, maybe you don't want to learn about that and learn about Go at the same time. So you can now use your own expertise to write the operators that you need. Basically, your code, everything it has to do is to run the reconciliation loop. So you need to run the reconciliation loop, and then you have to containerize that application, and that's it. That's your operator. The tricky part is that you have to query the Kubernetes API. So having a framework or some kind of SDK to query and not writing the REST calls by yourself, it's a better option, in my opinion. But yeah, whatever makes you comfortable, we'll do it. So here's my last slide. Now that you know what an operator is, you need to ask yourself, do I need one? If no, just move along. If you do, go watch the anti-operators YouTube videos. Look for when not to write an operator, when not to do this. And if you still think you need one, okay, check if there's one already available for you. If you don't find one, check again. It's probably one. And if you still don't find one, yeah, go ahead and build your own, and you have many choices for different programming languages you can pick from. So that's it for me. I kind of rushed it through, but I hope everybody understood. Thank you. Merci. That's all I know in French. I know a little bit, but I won't say it. Thank you.
Awesome, Sebastián. Thank you so much for this. I really feel like we need to do something with like the term external secret operator. I feel like there's going to be something cool that we can do with that.
Yeah.
So thanks for joining, and hopefully we will all get to see you when you move to our part of the world. We're looking forward to that. And we do have a question from Benjamin. Did you have any performance limitation, or do you know if some exist writing the operator in .NET and not in native Go?
That's a good question that I actually get asked a lot. That .NET that I wrote is .NET Core. .NET Core is a lot more performance than the old .NET framework we used to know. It runs on Linux, and there are benchmarks comparing the two with no major performance drop. There are some gains, actually. It depends on what you do. But answering the question, no, there are no major drawbacks on performance because of writing .NET.
Okay, excellent. And we have one more from Troy. A Kubernetes operator seems like a reusable deployment. Does it have any advantages over something like a Helm chart?
It is different in a way that there are 4 different scenarios, actually. I mean, you can use a Helm chart for Redis, and you can use an operator for Redis too. In that case, I would probably go with whatever makes you feel more comfortable. But the real scenario, in my opinion, for an operator is when you need to write your own reconciliation loop that I showed you. So when you need to write your own code, that's where nothing beats the operator. For the other thing, yeah, maybe you can use either of two. I've seen them use both. I've seen them use operators for Redis or Helm charts.
Awesome. Thank you. So we don't have any other questions, but if any come up in the next 2 minutes, feel free to post them. I would like to thank you, Kevin and Sebastián, for being here. You made this event possible, and we've gotten some really good feedback on the content. I think the quality as well as the topics you guys covered. So a big shout out to you guys, and thank you so much for making this event possible. And also thank you to everyone who attended. Merci beaucoup d'être là. Je m'ennuie beaucoup de vos visages. I think we're all kind of getting used to this online situation, but it's not great. And with that, I actually see there's one more question, if you guys don't mind, also from Benjamin. Question again for Kevin, if it's not too late. Do you have a specific environment, a container or CI pipeline to execute the Terraform commands, or do you run them directly? If yes, how is it set up?
So we do. Oh, so the main project I was working on, we were running them directly because we won't actually be designing the pipeline for the client, but we are also working to integrate this into our GitLab pipeline. And how that works is we've got our bunch of the variables defined within the pipeline in GitLab, and then we're using those throughout the deploy.
Thanks a lot. Okay, apparently you answered the question, so awesome. Cool. Well, thank you again. You can reach out to either myself or Ian. How to find us? I don't know, LinkedIn, Twitter. Troy also says that he uses Atlantis for Terragrunt pipeline.
Cool. I'll check that out.
Awesome. So thanks for sharing all the information, everybody. And yeah, we'll see you soon again.
Thank you very much for having us. Bye.
Thank you. Bye.